Hello, my name is Bob Gallagher. I've been with PennEngineering since 2018, and I serve as the product manager for the SI threaded inserts and compression limiters for plastic. So for today's agenda, we'll go over what are threaded inserts and why are they used, some common industry insert materials, the installation methods used, very critical to get that information. Solving technical issues. I'll go over some very common questions that may be posed with customers and designs that you'll be able to solve. Our flanged inserts and compression limiters. And last but not least, what to ask during the design process.
PennEngineering is over 80 years old, and we are strategically located around the world to support our customers. So you can be confident we can work with you from the beginning of a design idea straight through production anywhere in the world. PennEdge is a suite of free services to help you get the information you need to make an informed decision. With PennEngineering, you have the opportunity to work directly with our applications engineers at your convenience. You may choose this via either the online chat, or you could schedule a virtual consultation with them.
So here you'll see the cover to our SI threaded insert catalog. Alongside it is the classifications we apply to each installation method. And I hope to have you leave today with just a little more enlightened on the brand itself and the potential, as a lot of metal applications seem to be crossing over into composites and plastics. You'll see there's a lot of room for growth with this line, and you will be coming across these even more and more in the future. Common materials and finishes. We offer 3 catalog materials. All 3 will meet RoHS and REACH compliance. Those certifications can be found on our website. Specifically, our brass and our stainless steel will have less than 4% lead content. So the first and most common is our brass inserts. We make that from 360 series. It is basically the industry standard, generally the lowest cost, and will be the most prevalent. Second is stainless steel. We manufacture that in 303 series. It's the least corrosive, and we like to think we're one of the market leaders with that material due to our expertise on the PEM side. And last but not least, aluminum. Our aluminum is one of our newer materials. It was introduced back in 2017. We make that from a 2024 T4 series. And what's significant about aluminum is it's 70% lighter than brass and 100% lead free. So we feel it's going to be very important when used in some of these autonomous vehicle applications and a lot of just basically automotive applications where needing a lighter fastener is extremely important. We can apply commercial platings to our inserts. It's not very common, but you will see it in situations where you may need a coating due to the mating hardware being used, or some sort of plating used to make it less corrosive, I suppose. Those are available on request, and they will be considered specials. So what is a threaded insert? Basically, a threaded insert is a precision machined metal component or fastener, and it has engineered external features that are applied so that it can be secured into the plastic. Now, once an insert is in the plastic, it will serve as a thread so that mating hardware can be applied and used in the housing. Why are threaded inserts used? Well, threaded inserts are installed into plastics so that they create a strong reusable, and wear-resistant thread. So if mating hardware or a secondary part is needed to be installed or removed from a plastic housing, the insert will create serviceability. It also prevents the plastic from degrading. If you were to use a machine screw directly into plastic housing, you wouldn't be able to use it very long before it's worthless. Provides an electrical contact and connection point within the plastic housing. You'll often see brass used in this case because of its electrical conductivity, and sometimes flanged inserts that sit on the plastic surface. And throughout our catalog, you'll see our inserts are categorized with unified Class 2B dimensions and metric 6/8 dimensions. Applications for threaded inserts and compression limiters are endless. I'm often asked, so Bob, what industry will you see inserts used in, or what industry is most dominant, I suppose? And it's really hard to give a straight answer to that question. These inserts are found in every industry, and they truly are everywhere. Here on this screen, you'll see images of fairings for motorcycles and bikes. So they're in the automotive industry. Knobs, intake manifolds, pump housings. You'll see these inserts in meters and various telemetric devices. Taillight housings, compression limiters, control modules. This slide is a continuation to the last, again emphasizing how many industries and products actually include these inserts. You'll see various control modules, power tool housings. You check your own garage or your tool shed, you'll often find these inserts in John Deere tractors, DeWalt power tools, lawnmowers. Electric vehicles. We have inserts included in electric vehicle battery housings, dashboards, sunroof, plastic bumpers. I mean, if it has plastic, there's a possibility that an insert could be used. We're using handles. Handles often use threaded studs, which are specials for us. And medical devices. Medical devices are often using specific grades of material, 316 stainless or a 304, and micro-PEM threaded inserts that are used in a lot of handheld devices or electronics in your own home, speakers, maybe the laptop you might be listening to this from. So during the COVID pandemic, we saw a dip in the automotive industry's order rates. But where we saw an increase was in the medical industry. So many of these medical devices, these ventilators and respirators, we really saw an uptick in business there. And as you open the plastic housing to some of these medical devices, you'll see there it's littered with threaded inserts and compression limiters all throughout. Now keep in mind, quite often these threaded inserts are not really seen because they're always hidden behind a mating component. But rest assured, if you do see a plastic housing, just keep an eye out, ask questions, and your customer or whoever's working on a design will likely have those inserts included. Knowing the installation method is critical. It's one of the first questions you want to ask is what installation method do you have at your disposal? So in our catalog, we classify these in 3 categories. On the left, you'll see 4 bullet points, but it's because the ultrasonic and thermal heat staking method will use the same insert series. Next, you have your injection molded insert series or installation process. And last, your cold press. And we're going to go over each method in subsequent slides. Ultrasonic insertion. If you hover your mouse over this animation or this graphic, it will give you the ability to hit play, and you'll be able to see an animation, this process as I speak. So during this process, the insert is placed into molded or pre-drilled holes. Keep in mind, all of these installation processes, barring injection molded, will require a pre-drilled or pre-molded hole to start the process. You can't install an insert into a flat piece of plastic. So the insert is hit with an ultrasonic welding horn at 20,000 kilohertz per second. The vibrations travel through the insert and frictional heat is generated, melting the plastic in the localized area as the insert is driven into the part. The ultrasonic vibrations cease, the plastic resolidifies, and the insert is bonded into the plastic housing. Thermal heat staking insertion. Again, just a reminder, hover your mouse over the graphic, click the button, and you should see the animation. Once again, during this process, the insert is placed into the molded or pre-drilled hole. A heated probe comes in contact with the insert, heating it to a specific temperature above that plastic resin's melt temp. Localized melting will occur as the insert is driven into place. The probe is retracted, plastic cools and resolidifies around the insert. Heat insertion temperatures will vary according to the plastic. All plastics are different. They'll react different to various stresses and heats and temperatures and whatnot. So this is a question that comes up often when customers are having issues with their performance value or they're experiencing flashing. There's a general rule here, and it's if your plastic is not listed on the right side here, you want to set the machine up to 28 degrees Celsius, 50 degrees Fahrenheit above the melt temp found on the plastic resin's data sheet. Again, over here you'll see the starting temperature for each plastic that's recommended and a max temperature not to exceed. This often solves a lot of tech questions. Ultrasonic insertion versus thermal heat insertion. A lot of pros and cons to each method. So let's go over the advantages to the ultrasonic insertion. It's fast and reliable. It works well for most thermoplastics. It's easy to source the welders and the welding horns that they use, and you're going to get repeatable results. Now, some of the disadvantages. It's very noisy. If you've been to a dentist office and you heard that those ultrasonic machines, they can really bother your ears. It's the same with this. It's 10 times worse. It's more abrasive. You can risk damaging the insert itself. Create metal dust during the installation. Sometimes that dust gets into the threads. And you're limited to the number of inserts that can be installed at any given time. So now the advantages to thermal heat insertion. It's not abrasive, provides better plastic flow around the insert body. There's no metal dust created. Multiple inserts can be installed simultaneously. Better method for much larger inserts. And so it's possible to purchase tooling where your inserts can be installed on different levels simultaneously. So if you have let's say you have a large manifold for a vehicle with inserts that need to be inserted a few inches, millimeters away from each other in height, this would be the best method. Tooling and equipment and maintenance are considerably lower than ultrasonic. In some cases, almost half the cost. The disadvantages. It's slower when you're installing one insert at a time. You have to wait for the insertion probe to cool with each installation. And again, longer cool time necessary for each insert. Most common threaded inserts for ultrasonic and thermal heat insertion. Here is basically a summary page of the insert series found for this method. Across the top, you'll see our IU, well, for sake of consistency, I'll reference these by their brass callout. So you'll see the IUB and the IUTB series. Those are probably our two top selling lines. So the IUB series on the top left, that's a tapered insert. The body's tapered so that you can orientate the insert easily into the pre-molded or pre-drilled hole. A lot of customers like using that, and it's industry standard. It crosses to every other competitor, and a very, very prevalent part in the insert industry. Below that, you'll have our ISB series, a symmetrical through-threaded insert. Many customers use this during automated processes. So if you dump that insert into a bowl feeder, and as it shuttles its way down through a vacuum tube to the insertion point, due to its symmetrical shape, it makes that process much easier. At the bottom, you'll have our flanged straight wall insert series. We'll get into the reasons for this flange in another slide. It's a relatively new line for us. And on the right side, you'll have the MSIB insert from our MicroPen brand. That insert, very, very small. Threads go down to as small as an M1 thread. And you'll see, as I mentioned previously, you'll see a lot of those in small electrical appliances. Molded in installation. Keep in mind, with this installation, you're not using any sort of pre-drilled or pre-molded hole. The inserts are installed during the injection mold operation. So how this is performed is the insert is placed on a core pin in the injection mold, and the plastic is released into the cavity and molded around the insert. Proper pin size is critical. It's very important that that insert is seated all the way onto the pin, and it fits nice and snug so that there's no plastic creeping into the threads. In our molded in installations, we offer a series that will have a blind or closed bottom hole. And the reason for this is to prevent plastic flow from getting into the threads during the installation process. Unfortunately, with this insert, we're unable to drill all the way to the bottom of the insert. We can drill approximately 2.5 threads beyond the minimum thread depth. That's because we prefer to use form taps during this process, which will eliminate any chips or shavings that will fall into the insert, rather than cut taps that are used for other inserts. Of course, you can use through-threaded inserts with this installation method. It's important to ensure that the tolerance of the pin you're using, there's a very tight tolerance with that and the thread miner, and that'll prevent plastic from creeping into the insert. Advantages and disadvantages of a molded in insert. Go over advantages first, and if there's one thing you take from this slide, please realize that the performance method or performance of a molded in insert, how it performs with pull out and torque out, this is the best method. This will have the best values than all the other installation methods. You get excellent plastic flow around the insert. There's no secondary assembly or secondary processes involved, and multiple inserts can be installed during the cycle. So disadvantages. You have longer cycle times. It's the most expensive installation method of them all. I mean, the machinery involved is quite costly. Plastic can get into the threads, mold damage possible if misloaded. A lot of this has to do with the machine operator and their experience. If you find that the plastic part is defective, inserts need to be removed before the plastic can be reground, and removing that insert can be quite difficult. Molded in, stress, and possible sink marks can occur. The most common threaded inserts for molded in applications. Here in our catalog we have four series. We have our IBB series. It comes in a number of lengths. It is a blind hole to prevent plastic creeping. Below that we have our through threaded insert, an ITB series. The top right we have our self-locking blind threaded IBLC series. This is not available in brass, but what's unique to this insert is that it has a self-locking thread. It's very prevalent and used quite a bit in the aerospace industry, because when you apply mating hardware, if there's any vibration in the environment it's in, you want to ensure that your mating hardware doesn't slip out. And at the bottom, also bottom right, our STKB series, available in I think it's available in more lengths than any other series in the catalog, and this one is quite a popular insert due to its various lengths and threads. And this brings us to our last installation method, the cold press insertion. Again, we press these inserts into pre-drilled, pre-molded holes. It eliminates the need for any heat or ultrasonic equipment. There's no melting of the plastic involved, but keep in mind this is the least effective as far as insert performance for pull out and torque out. Again, it's also the least expensive too, and this insert can be installed with a standard arbor press similar to our PEM clinch fastener. Most common threaded inserts for press-in applications. On the top left we have an insert that's hexagonal in shape. It's unique to PEM. We designed this, and to the best of my knowledge, it has not been crossed or copied by any competitor to date. It has very aggressive barbs, not knurls, and due to its holding values as a cold press insert, it's it is our best-selling insert within this series. Now the other three insert series, your PFLB with a flange, your PPB and PKB, you'll see that all three of these have a slot cut through the body. There is a reason for that slot, and as you press the insert into its hole, the body with those slots will collapse in on itself. And where the bond in the plastic happens is as you apply your mating hardware, that collapsed wall will open and adhere to the plastic in the hole. Our new flanged threaded insert. This is used with ultrasonic and thermal heat insertion. So when I started with the company a few years back, this was one of the big hole in the catalog, if you will, the product that needed to be added ASAP. And so with this series, it creates a larger surface area for higher pullout if you're applying your mating hardware on the bottom or the reverse entry. The brass flange offers a contact surface for electrical connections. Many times assemblies will require not having your mating component come in contact with the plastic. That's where you'll have the flange sit on the surface. Very few cases, but it does happen. Customers will bury the flange flush with the plastic, but you won't see that very often. This flange is used to distribute the load applied when you're fastening the mating hardware. The self-aligning lead-in or C dimension, pilot dimension. It's going to provide accurate alignment prior to the installation, so you'll be able to orientate that somewhat in the pre-drilled hole. This insert needed to get into the catalog as quick as possible, so we haven't yet introduced it in aluminum or stainless. That is available upon request and will be treated as a special. Common hole prep configurations. As I've said throughout this presentation, that you do need to pre-drill or pre-mold a hole before installation, and in doing so you're often posed with dimensions. The dimensions needed for a hole can be found in our catalog. Just keep in mind these are recommended hole depth and hole diameter dimensions. Every plastic again is different, so sometimes the depth and diameter of the hole may need to be tinkered with and adjusted. But the proper hole emboss diameter plays an important role. And a lot of that has to do with how the insert stays in the plastic or how it's held. So there's two standard hole configurations commonly used. You'll have an 8-degree taper, which is often used with our IUB tapered insert series. And in most others, you're going to find a straight hole or a slight 1-degree taper found or needed for installation. One of the most common tech support questions I'm posed with is how much of a wall or how much plastic material do you need around an insert for it to reach peak performance or maximize performance. So this wall of plastic around an insert is often called the boss wall or boss diameter. We recommend that you install an insert with a boss diameter 2 times the insert diameter. That will get you optimal performance. It is possible to go lower, decrease the diameter down to as much as 1.5, maybe 1.25 times the insert diameter. I suppose, it depends on the application. Every application is different, and every insert undergoes a different criteria when it comes to stresses and usage. Key insert features. Well, if you look at the images on this screen, you'll see that they all have different knurls and undercuts and shapes and sizes. There is a rhyme and reason as to why each specific knurl pattern and design is allocated towards a specific installation method. This knurling is going to provide you with a improved torque out performance, while undercuts are usually going to help with your pullout. Again, the longer the insert, the better the pullout value, and the wider the diameter, the better the torque out values. But here you'll see diagonal knurls and the inserts on towards the top, opposing diagonal knurls. It's best used with heat staking and ultrasonic pressing. Your diamond knurls are often applied to molded in inserts. And at the bottom, you'll have our hex-shaped insert, helps with torque out, and that's specifically for press-in applications. And as previously explained, the reason for those slots also applied to press-in inserts. But you'll soon learn that each of these profiles, you'll learn which ones will apply to what installation method. Common performance test methods, just like our PEM clinch fasteners, 2 critical data points are your pull-out and your torque out. We have a lab in our Winston-Salem facility, our Kunshan facility, and our Danborough facility that we will, at no charge, take your installed inserts in your material and provide you with pull-out and torque out results. We can usually turn that around in about a week. And if that's not possible, we will offer you free samples so that you can test in-house if needed. Again, this is a free service that we welcome if it helps you get closer to the information you'll need. Test data. At the end of each series in the catalog, you will see a page dedicated to performance testing. Now, we inherited this information from Standard Insert when we purchased them some years ago. And this information is only given, this test data is only given in two different plastics, ABS and polycarbonate. To the best of my knowledge, no other competitor really offers test data in anything more than two plastics. There's just too many plastic resins out there for us to actually have all that information collected. But if your customer has if the customer has a plastic not found here, we will test it in-house in our lab at no charge. Throughout the catalog or test data, you might find an odd length or thread missing. Rest assured, I'm in the process of trying to get all the holes of missing data filled in the catalog over the next few years. Design guidelines to avoid what's known as a jackout condition. We do recommend that inserts be installed flush to the surface for the best performance, neither below it or above it. Often the hole in the mating part must be smaller than the insert diameter in the host to prevent the insert from pulling out through the assembly, known as a jackout method. So be aware of this. This is often a question that's posed through a tech support line. Compression limiters. Again, when I began with the company, I started seeing a lot of inquiries about a compression limiter and whether or not we had inventory. So I conducted a study to find out if there was any common theme, size, shape, profile with these compression limiters. And compression limiters truly are unique to its specific assembly. So it made no sense for us to create a part number series for the catalog. So we created a compression capability page. So what is a compression limiter? A compression limiter is a non-threaded insert that's used in applications where a compressive load is applied to the plastic assembly. The compression limiter will strengthen the joint and it will withstand the compressive force that is applied when the mating screw is tightened in the assembly. So it will basically prevent cracking at the joint. So this compression limiters will be custom designed. It will be specials with 5,000 piece minimums. They're available in all sorts of materials: brass, stainless steel, lead-free aluminum. We can look into other materials if necessary. They're installed through all the basic methods, and as you can see here, there's a lot of different variations. Flange head and even non-knurled insert or compression limiters are available. So questions you should ask for choosing an insert or helping your customer with the design. What exactly is the application? Are we replacing a current source, or is this a new program? What type of plastic is the customer using? Do they have a preferred installation method? Understanding what installation methods you have at your disposal will give you a wider choice. The basic dimensions, your thread spec, your length, your through hole or blind hole. Is there a specific material or plating needed for the insert? Strength requirements. Often strength requirements are not known until the physical insert has been sampled and tested. and quantity and when the project may start. This very same set of questions could be applied to any brand within the PennEngineering family in order to get all the information needed for a quote. Which insert should I choose? Well, you've gathered all your information. You've been advised or have advised on the pros and cons of the many choices. And now it's up to you and the customer to determine whether or not you need to go with a custom insert or whether they can choose a catalog insert. I mean, of course, we would prefer a catalog insert just to, the cost and the lead time and whatnot, but we can customize inserts. It's probably about a quarter of our business. So please give us the opportunity if need be. SI battle cards. Now, battle cards have been created for every brand within the PennEngineering family, or at least most. It's going to be, it is a 2-page laminated back to front guide to help you to assist you on sales calls. It's almost like a cheat sheet for a threaded insert, and it'll give you the installation technique or methods. It'll give you the profiles, advantages to using SI, why you might want to use a threaded insert over other fasteners, technical information, key questions to ask when seeking the business. So we hope you use these to help you capture all the buzzwords and highlight all the main topics you need when you're trying to work on a design.
With our global footprint, we are there to serve you throughout the world. We can work with you from the beginning of the concept straight through to when it comes off the production line.
Thank you again for spending the time today to listen to this presentation. I hope you're able to I hope you've learned something new about threaded inserts and the SI brand. And if you have any questions, please don't hesitate to contact your local PennEngineering rep, or you can contact si@pemnet.com for any threaded insert inquiries. We'd be glad to help from design all the way to production, through production, and into your customers' hands. Thank you again. Bye-bye.